Hi, my name is Terence Serrano and we are reporting about digital television. And by the way, we are Group 5. Digital TV or DTV. History. The switch from analog to digital broadcast television is referred to as the digital TV or DTV transition. In 1996, the US Congress authorized the distribution of an additional broadcast channel to each broadcast TV station, so that they could start a digital broadcast channel while simultaneously continuing their analog broadcast channel. James Liedenberg, an American engineer dubbed as the father of Philippine television, began assembling transmitters and established the Bolinao Electronics Corporation or BEC on June 13, 1946. 3 years later, he was the first to apply for a license in Philippine Congress to establish a television station. After a year, on June 14, 1950, his request was granted. Due to the scarcity of raw materials and strict import control since 1948, he was compelled to branch into radio broadcasting instead. Liedenberg's attempt to put a television station did not go to waste. Judge Antonio Quirino bought 70% share of BEC stocks, which earned him to control the franchise indirectly. He then changed the name of BEC into Alto Broadcasting System. Finally, on October 23, 1953, Judge Quirino marked the first official telecast in the Philippines. The ABS studio was a makeshift barn along Florentino Torres Street in Manila, except for the 4 engineers who was sent to the US for training. Most of the personnel at ABS learned TV operations on the job. The first transmitter is at station located at San Juan. In 2007, ABS-CBN Broadcasting Corporation applied a license to the National Telecommunications Commission or NTC to operate a digital terrestrial television service in the country. In 2008, Sky Cable became the first cable network to adapt to digital television, and Signal, the first digital broadcast station television service, made its debut in February. In 2009, ABS-CBN started to test digital transmission using the European DVB-T standard. On July 11, 2009, ABS-CBN launched Balls HD in Sky Cable, the first ever high-definition television channel in the country. In the same day, Balls also showed the live broadcast of the first ever locally produced coverage of an event in high definition. In 2010, government-controlled television stations in Manila started to test digital transmission using Japanese ISDB-T standard. In June 2010, NTC announced that the country will formally adapt to ISDB-T standard for digital terrestrial television. However, GMA Network opposed the decision made by NTC and asked NTC to reconsider the European DVB-T for its superior quality. The Commission will be using the ultra-high frequency television channels from 14 to 51 or 470 to 690 MHz for the establishment of DTT service, and liberating channels 14 to 20, which is also 470 to 512 MHz, which is being used for fixed and mobile service. There are more than one type of digital television service. Here is a brief lowdown on the types you're likely to encounter. Digital terrestrial, digital satellite TV, digital cable TV, Internet Protocol Television. Digital terrestrial television or DTV or DTT is an implementation of digital television technology to provide a greater number of channels and or better quality of picture and sound using aerial broadcast to a conventional antenna or aerial instead of a satellite dish or cable connection. ABS-CBN Corporation intends to spend 1 billion pesos on its transition to digital broadcasting. On February 11, 2015, ABS-CBN launched ABS-CBN TV Plus, a digital TV service becoming the first TV network in the country to commercially launch DTT. The state broadcaster People's Television Network, Incorporated began DTT trials using ISDB-T in 2009. Used channel 48 or 677.143 MHz. PTV4 is also planning to operate an emergency warning broadcast system or EWBS using the digital platform. PTV currently uses channel 42 or 641.143 MHz. TV5 Network, Incorporated uses ISDB-T for its DTT trials. Currently, 5 is broadcasting on channel 51 or 695.143 MHz. TV Network, Incorporated uses ISDB-T for its DTT trials. Currently 5 is broadcasting on channel 51 or 695.143 MHz. GMA was vocal about the NTC's choice of DTV standard. On March 27, 2011, a GMA executive proposed to use the updated European standard DVB-T2 as opposed to ISDB-T due to its better quality. However, the NTC did not change the decision, and after few years, they are all ready to adopt the ISDB-T standard. Currently, they are broadcasting on digital channel 15 or 479.143 MHz on ISDB-T. Net25 and INC-TV, BIM, Broadcast Enterprise and Affiliated Media Incorporated, SEC, Solar Entertainment Corporation, SMNI, Sunshine Media Network International, Hope Channel Philippines and GNN, CNN Philippines, and Light Network. These are the examples of digital terrestrial TV. IBC, Intercontinental Broadcasting Company, DZRH, DZRH Television, Manila Broadcasting Company, UNTV, Progressive Broadcasting Corporation, RJTV, Raha Broadcasting Network. These are examples of the broadcast company and broadcast corporation which can produce digital terrestrial TV.
My name is Joshua and I'm going to discuss digital satellite TV, digital cable TV, and Internet Protocol TV. For the digital satellite TV, satellite television is television signals delivered by means of communication satellites and received by satellite dishes and set-top boxes. In many areas of the world, it provides a wide range of channels and services, often to areas that are not serviced by terrestrial or cable providers. The Signal is also a digital satellite TV, and its parent company, Mediascape, invested 1.5 billion in the implementation of its digital satellite TV services. Signal uses the DVB-S2 standard for its digital satellite platform. DVB stands for Digital Video Broadcasting Satellite, and it's using second generation. For GSAT, Global Satellite, GSAT is a first United Broadcasting Corporation and Global Broadcasting Media Incorporated. Company is one of the newest subscription-based direct-to-home satellite television services in the Philippines. Channel content in this direct-to-home satellite TV service provider is received from program providers, compressed and broadcast via SES New Skies, NSS9. These are the satellites being used in digital video broadcasting S2 color format exclusively to its subscribers using the integrated receiver decoder. SkyDirect is the newest direct broadcast satellite (DBS) service provider in the Philippines. It is owned and operated by Sky Cable Corporation, a subsidiary of ABS-CBN Corp. On December 23, 2015, Sky was granted a provisional authority by the NTC to operate and maintain a DBS service in the country for a period of 18 months and plans to spend at least 252 million for its initial rollout. It is being carried by SES and SS11 satellite using DVB-S2. This digital television broadcast standard in the Ku band and Varimatrix encryption system to protect its content from signal piracy. Cable television. Now we move for digital cable TV. Cable television or community antenna television (CATV) is a system for distribution for audiovisual content for television, FM radio and other services to consumers through fixed coaxial cables. Avoiding the traditional system for radio broadcasting antennas, broadcast television and have widespread use mainly through the pay TV services. Sky Cable is an example of the digital cable TV, and in October 2010, Sky Cable announced it would migrate at least 80% of its subscribers in Metro Manila to a digital cable platform with new digiboxes by 2011. Sky Cable allocated 20% of its 1 billion capital expenditure in order to fund the migration. Sky Cable adopted the DVB-C standard for its digital cable system. The new platform also allowed Sky Cable to additionally introduce the high-definition channels to its lineup. Destiny Cable. In March 2009, Destiny Cable began to offer its own digital cable services, investing 500 pesos to 700 million pesos on head-end and infrastructure updates and the distribution of digital set-top boxes for its subscribers. The Parasat Cable TV provider of Mindanao. It is the provider of Mindanao. Introduced digital cable in July 2009. It has rolled out its services to Cagayan de Oro City, municipalities of Apol and Tagalon in Malay and San Carlos, Negros Occidental, Ganaog City, municipalities of Balingsasag, Don Carlos and Valencia City, Bukidnon, and in the east and west sides of Misamis Oriental. For the Internet Protocol TV, otherwise known as IPTV, Internet Protocol Television uses a broadcast connection to provide digital television services to your home. It is also the delivery of TV content over Internet Protocol Network. Unlike downloaded media, IPTV offers the ability to show the source media continuously. So here are the examples of IPTV. We are given Netflix, iFlix, Hook, iWant, Fox Plus, HBO Go, and Vayu.
Hi sir, I'm Stephen Tan and I'm going to report about the different DTV standard and the comparison of analog and digital television. So the first one is the ISDB. known as the Integrated Services Digital Broadcasting. It is a Japanese standard for digital television and digital radio used by the country's radio and television networks. It is maintained by the Japanese organization ARIB. The standards can be obtained for free at the Japanese organization DIBEG website. The core standards of ISDB are ISDB satellite television, ISDB terrestrial, ISDB cable, and 2.6 GHz band mobile broadcasting, which are all based on MPEG-2 or MPEG-4, which is standard for multiplexing with transport stream structure and video and audio coding, known as MPEG-2 or H.264, and are capable of high-definition television known as HDTV and standard definition television. ISDB-T and ISDB-TSB are for mobile reception in TV bands. The various flavors of ISDB differ mainly in the modulations used. Due to the requirements of different frequency bands, 12 GHz band ISDB-S uses PSK modulation. 2.6 GHz band digital sound broadcasting uses CDM. And ISDB-T in very high frequency and or ultra high frequency band uses COFDM with PSK or QAM. Digital video broadcasting or DVB-S2 satellite second generation is a digital television broadcast standard that has been designed as a successor for the popular DVB-S system. It was developed in 2003 by the DVB Project, an international industry consortium, and ratified by ETSI or EN 302-307 in March 2005. The DVB-S2 achieves significantly better performance than its predecessors, mainly allowing for an increase of available bitrate over the same satellite transponder bandwidth. The measured DVB-S2 performance gain over DVB-S is around 30% at the same satellite transponder bandwidth and emitted signal power. With the contribution of improvements in video compression is added, an MPEG-4 AVC HDTV service can now be delivered in the same bandwidth that supported an early DVB-S-based MPEG-2 SDTV service only a decade before. Next, the DTV standard or DVB-S2, its main features. The direct input of one or more MPEG-2 transport streams (TS) is supported using a compatibility mode. The native stream format for DVB-S2 is called generic stream or GS and can be used to efficiently carry IP-based data, including MPEG-4, AVC or H.264 services. For the continuation of its main features, there are four modulation modes. QPSK and 8PSK are proposed for broadcast applications and can be used in nonlinear transponders driven near to saturation. 16 APSK and 32 APSK are used mainly for professional semi-linear applications, but can also be used for broadcasting through they require a higher level of available CRN and an adoption of advanced pre-distortion methods in the uplink station in order to minimize the effect of transponder nonlinearity. Next, the DTV standard or DVB-C. The DVB-C stands for Digital Video Broadcasting Cable, and it is the DVB European Consortium's standard for the broadcast transmission of digital television over cable. This system transmits an MPEG-2 or MPEG-4 family digital audio or digital video stream using a QAM modulation with channel encoding. The standard was first published by the ECSI in 1994 and subsequently became the most widely used transmission system for digital cable television in Europe, Asia, and South America. It's deployed worldwide in systems ranging from the larger cable television networks or CATV down to smaller satellite master antenna TV SMATV systems. So for the DTV standard DVB-C, the available bit rates for a DVB-C system is shown below with the appropriate modulation. Example is for the 16 QAM with a bandwidth of 2 MHz. We will have a bitrate of 6.421, and for a bandwidth of 4 MHz, we will have a bitrate of 12.82, while 19.23 bitrate for a 6 MHz bandwidth, 25.64 for an 8 MHz bandwidth, and 32.05 MHz 10 MHz for a 32.05 bit rate. And the 32 QAM, 64 QAM, 128 QAM, and 256 QAM are as follows for their specific bit rates. So why do we choose digital TV over analog TV? It's because analog TV is prone to fading, snow, and ghosts. Digital TV reproduces crystal clear picture and sound without fading or interference, superior image resolution, detail for a given bandwidth, smaller bandwidth for a given image resolution. We have a compatibility with computers and the internet. It has superior audio quality. It has consistency of reception over varying distances. It's a digital technology that also enables TV stations to broadcast multiple channels with different programming. So the video that I'm about to show you is the comparison of analog versus digital, their difference, and how do they work together to make modern life possible.
For a while now, the word digital has been slapped on so many things that it's sort of become a marketing buzzword to convince people that something is high tech or better in some way. Of course, most modern electronics are digital by definition as opposed to analog. But what do these terms even mean, and is digital necessarily even better? For a long time, most consumer electronics like televisions and cassette decks worked by using analog signals, which you can think of as being similar to one of those wall clocks with a perpetually moving second hand. Just as the second hand continuously moves to represent the time, analog signals use some type of thing that's constantly changing to represent data. For example, both AM radio and old school broadcast TV use a signal with a continuously variable wave height or amplitude to represent sounds or visuals. These sorts of analog waves can be decoded or demodulated fairly easily with diodes that can relay actual data to a screen or a speaker. But as any child of the 1980s who grew up watching rabbit ears connected TVs or dubbing cassette tapes knows, a massive drawback to analog tech is the possibility of interference. The variations in waves that encode analog data are so small that interference can easily disrupt the analog waveforms and cause snow on your TV, static on your radio, or even problems with monitors that use older VGA cables, which are actually analog despite most other modern computer components being digital. Digital technology attempts to solve this problem by encoding and transmitting data as clear-cut, discrete units, namely ones and zeros, instead of always changing waveforms that are super sensitive to interference. These ones and zeros are actually just representations of electrical signals being on or off. When you view it on a square wave, that's either up or down. These positions are easy representations since any piece of a square wave can only be read in one of two states, on or off, up or down. They aren't nearly as vulnerable to interference, making digital transmission normally a heck of a lot more reliable across longer distances, which is why the length of speaker wire in your home theater matters, but the length of a digital HDMI cable usually doesn't, at least not for resisting interference. And since digital data is stored as an exact finite set of ones and zeros, it can be perfectly replicated anytime you need to make a copy, unlike analog recordings that degrade over time due to the difficulty in duplicating an analog wave at every single point. This is the reason that an MP3 copied to a million iPods will sound the same on every one, but a cassette tapes that are copied a whole bunch will eventually sound like garbage after you dub them enough times. But even though digital has obvious advantages, we live to a great extent in an analog world. Take the sound, for instance. The sound waves that come out of your mouth when you talk are analog in nature. So how does a singer record albums that are stored digitally on, say, a Spotify server? Well, digital recording primarily works by sampling instead of recording all of the infinitesimally small changes in an analog waveform. An analog to digital converter takes snapshots of analog sound or video and stores them as digital bits. This is typically done many times per second, with higher sampling rates resulting in more data and usually better quality, allowing a digital recording to achieve pretty close fidelity to the original performance while taking up much less space on a disc. Of course, since you can't exactly hear ones and zeros, digital recording sound needs to go back through a digital to analog converter, or a DAC, which will convert your MP3 or AAC to an electrical signal that has a constantly changing voltage that the drivers in your headphones will turn into actual sound. So while digital tech has been extraordinarily useful, it's really the way that digital and analog work together that makes the brave new world of tweets, Netflix, and dank memes possible. Speaking of digital things, Audible.com is the leading provider of audiobooks, with more than 180,000 downloadable titles across all types of literature, including fiction, nonfiction, and periodicals. Audiobooks are a great way to listen to something while you're, say, in transit on your way to work, or just trying to run around the track at school and you're super bored and whatnot. Anyways,
So the next reporter will be Joshua Marquez.
Hi. Hi, my name is Joshua Marquez and I will continue the discussion, and our topic will be the color television. So first, a summary of the contents on this part would be the definition, the history, the video basics, the TV transmissions, and the broadcast TV systems. So first, a brief discussion. Color television is a television transmission technology that includes information on the color of the picture, so the video image can be displayed in color on the television set. It is an improvement on the earliest television technology, monochrome or black and white television, in which the image is displayed in shades of gray or in grayscale. So here's a brief timeline. In the 1956, NBC began using color film to time delay and preserve some of its live color telecasts. In 1958, a company named Ampex made a color videotape recorder and used it to tape an evening with Fred Astaire. In 1961, Walt Disney's Wonderful World of Color created a turning point that persuaded consumers to go out and purchase color televisions, and in the late 1980s, all broadcasting networks switched to color sets. Now for the human perception of motion. Television technology must deal with the fact that human vision employs hundreds of thousands of separate electrical circuits located in the optic nerve running from the retina to the brain, in order to convey simultaneously in two dimensions the whole content of a scene on which the eye is focused. In electrical communication, however, it is feasible to employ only one circuit, or in this case, the broadcast channel, to connect a transmitter with a receiver. This fundamental disparity is overcome in television practice by a process known as image analysis, wherein the scene to be televised is broken up by the camera's image sensors into an orderly sequence of electrical waves, and these waves are sent over the single channel, one after the other. At the receiver, the waves are translated back into a corresponding sequence of lights and shadows, and these are reassembled in their corresponding positions on the viewing screen. Next. So here we have the image analysis, wherein the requirements to be met in image analysis is the flicker, the resolution, the picture shape, and the scanning. So next, flicker. The first requirement to be met in image analysis is that the reproduced picture shall not flicker, since flicker induces severe visual fatigue. Flicker becomes more evident as the brightness of the picture increases. If flicker is to be unobjectable at brightness suitable for home viewing during daylight as well as evening hours. The successive illumination of the picture screen should occur no fewer than 50 times per second. This is approximately twice the rate of picture repetition needed for smooth reproduction of motion. To avoid flicker, therefore, twice as much channel space is needed as would suffice to depict motion. So as you can see at the pictures in this PowerPoint, the first picture you will see the steady of the, I believe that is a ruler. Oh, it's the measuring tape. Sorry. And at the second bottom image will be the when you move it. So the flicker is that motion itself, where when you capture it by the camera, the motion that is being made is the flicker. So that is sometimes we try to avoid that, so that the image to be sent by the channel will be clear as possible. Next will be the resolution. The resolution is the number of pixels used to make up an image. Higher resolution displays allows you to see more fine details in your favorite games, movies, and TV shows. So in this case, the resolution can be easily seen in our everyday lives, especially now because the highest quality you can see in an image in YouTube is a 4K, and the lowest will be 144p, wherein which you will see the difference is that in 144p, the pictures would be seen as a large group of squares itself, wherein at the 4K, even the pixels itself are so small that you can see the fine details of the complete image. Next will be the picture shape. Sorry. The universal picture is a rectangle that is 1/3 wider than it is high. This 4:3 ratio or aspect ratio was originally chosen in the 1950s to match the dimensions of standard 35 mm motion picture film prior to the advent of widescreen camera, in the interest of televising film without a waste of frame area. So before we had the rectangular area, we had a square shape, wherein you can see at the image for the SCTV, that was the common shape of the video capturing devices. And as we go on in time, we have the HDTV, we have the shape as a rectangular itself, so that we can maximize the viewing of on the TVs, and we won't have the black spots where normally we'll see in the cinemas, where in the top and bottom are the black spots, right? Normally they want to avoid that so that we can maximize the usage of the canvas or the TV. Next would be the interlace scanning. So the geometry of the standard scanning pattern is, as displayed on the standard television screen, consists of two sets of lines. One set is scanned first, and the lines are so laid down that an equal empty space is maintained between lines. The second set is laid down after the first, and it is so positioned that its lines fall precisely in the empty space of the rest set. The area of the image is thus scanned twice, but each point in the area is passed over only once. This is known as interlace scanning, and it is used in all of the standard television broadcast services of the world. So here you can see the first image or A lines, the first lines to be scanned, and you will see that there's black spots in there. And then for the second scan or the B lines, that The black lines, as you see in the A lines, are the ones being scanned right now, and the black lines you can see in the B were the first lines you will see in A. So that after those two scans are made, they will be just overlap, and you can see the combined image in the PowerPoint. The A and B lines combined, but the complete image can be seen. So the first field is made up of evenly spaced scan lines, and the second field whose scan lines fall between the A lines of the first field. The interlaced fields follow each other so rapidly that they combine in the viewer's eye to form a complete image. So that will be the first part of the color TV, and I will now to continue. Oh, I'm sorry. The next speaker for the color TV would be Ziad El Sakir. So, okay.
My name is Jada Sair and I will be talking about compatible color television. It represents electronic technology at its pinnacle of achievement, carefully balancing the need of human perception with the need for technological efficiency. So now we'll be talking about the different television systems of the world. We have three different systems. The NTC, which stands for the National Television System Committee, the PAL, which stands for the phase alternating line, and then the SECAM stands for the sequential color with memory. So NTC is used in countries like North America, South America, and Japan. It uses 525 fields and 30 frames per second. PAL is used in countries like the United Kingdom and Germany. It uses 625 fields and 25 frames per second. And SECAM is used in countries like France and Eastern Europe. It uses 625 fields and 25 frames per second. So the NTC was developed in the 1940s, and then after that came the PAL and SECAM, which was developed in the 1960s. So here is the world map of the countries that uses the different systems. So the green part of the map uses the NTC, the orange part uses the SECAM, and the blue part uses the PAL or SECAM. Okay, now we'll be talking about the transmission and reception. So transmission, the color television signal actually consists of two components, luminance and chrominance. And chrominance itself has two aspects, the color and the intensity of the color. The television camera does not produce these values directly, rather it produces three picture signals that represents the amount of the three primary colors. The three primary colors are blue, green, and red. Present at each point in the image pattern. From these three primary colors signals, the luminance and chrominance components are divided by manipulation in electronic circuit. So luminance is a weighted sum of the three colors of light used in color television and computer displays, which are red, green, and blue. At a given point on the screen, a strong luminance signal indicates a more intense brightness of light at a given spot on the screen. Chrominance describes the frequency of light at a given point on the screen, or in more common terms, the color of the light to be produced at a given point. It also specifies what color is to be shown at a given point on the display, as well as how saturated or intense the shade of color that is shown. So luminance and chrominance together luminance indicate how bright a given location on the screen is, and chrominance specifies how close to not have a color, just being white, or how intense the shade of color at the brightness specified by the luminance should be. When combined, the primary colors red, green, and blue, as you can see in the picture, yields another color. When all these colors were combined, they produce a white color. Generating the color picture signal, the television camera produces three picture signals that represent the amount that represent the amount of three primary colors, blue, green, and red, present at each point of the image pattern. The color code converts the primary color signal into the luminance and chrominance signal. The luminance and chrominance components are then combined in another addition circuit to form the overall color picture signal. Finally, horizontal and vertical addition currents, which produces the scanning in three camera sensors, are formed in the scanning generator, the timing of which is controlled by the chrominance subcarrier. So now we'll discuss the TV cameras. Cameras is the first and basic equipment in a TV. The input to a camera is the light from the picture or scene to be televised, and output obtained from the camera is the electrical pulses corresponding to the information contained in picture. The basic principle of all TV cameras, based on the fact that each picture of all TV cameras may be assumed to be composed of small elements with different light intensity. So here we have a picture of like the inside of the camera. So at first we have the lens, the white light coming from the filmed object will enter the lens, and then it will passes through a beam splitter, which will divide the colors into the green, red, and blue, and then it will passes it through a circuit which mathematically synchronizes and combines the output from the red, green, and blue image sensors to make a single video signal based on components called luminance and chrominance. Another part of the circuit instantly recreates the image being filmed on a small screen in a viewfinder. Meanwhile, sound from a microphone is synchronized with a video signal to produce an output signal ready for transmission. The carrier signal. Frequency shifting from broadcast over the air or transmission over cable networks must be shifted to appropriately higher frequency channel, which is accomplished in the transmitter, which essentially performs two functions: generation of a very high frequency VHF or ultra high frequency UHF carrier current for picture and sound, modulation of those carrier currents by imposing the television signal onto the higher frequency wave. The sound signal. The sound program accompanying a television picture signal is transmitted by equipment similar to the used for frequency modulated audio broadcasting. In the NTC system, the carrier frequency for the sound channel is spaced 4.5 MHz above the picture carrier and is separated from the picture carrier in the television receiver by appropriate circuitry. The stereo information encoded as the difference between the left and right audio channels, amplitude modulation, the stereo subcarrier, which is suppressed if there is no stereo difference. And lastly, we will be talking about the reception. At the television receiver, the sound and picture carrier waves are picked up by the receiving antenna, producing currents that are identical in form to those owing in the transmitter antenna, but much weaker. These currents are conducted from the antenna to the receiver by a lead-in transmission line, typically a 12 mm 1/2 inch ribbon of plastic in which are embedded two parallel copper wires. This form of transmission line is capable of passing the carrier current to the receiver without relative discrimination between frequencies on all the channels to which the receiver may be turned. Thank you.